welcome to another Scienthistics video. Today we will be covering Thursday 17th January 2019 Physics Paper 2P Unit 4 PH0. This also hasn't been released by Edexcel yet, but still we managed to get a copy, and today we're gonna be solving it. So let's move on with it. Here's the instruction, information and advice. Everyone should be reading this. You can pause the video and carry on if you like, but right now we'll be moving forward. Here are the equations. Some of these come handy in exams, so we'll just be keeping this aside. Okay, question number 1. Planets and moons in the solar system move in orbits. Name the force that causes planets and moon to move in orbits. So name the force. So everyone knows this will be gravitational force. Make sure to write the full words. Sometimes it's a little risky not to. Okay, part B. The diagram shows the orbits of a planet and a moon in the solar system. The diagram is not to scale. Here's the diagram. On the diagram, label the planet, the moon and the sun. So we're not doing this in respect to the galaxy and only with respect to the solar system. So we know that the sun does not move in an orbit and is stationary. So the only thing over here without an orbit is this ball. So we're gonna write this as sun. Earth, we know, orbits the sun. So here we know this is the earth. And last thing, moon orbits the earth. Or you can just label the planet over here instead of earth, the moon and the sun. But it's okay if you write earth because earth is a planet. Part 2. Explain how the time period of the moon's orbit is different to the time period of the planet's orbit. So for example, there's a racetrack. We'll just take this. This is a smaller racetrack and this is a larger racetrack. On which racetrack would the car take lesser time to complete a circle? Obviously the moon's, the smaller one. So here we can conclude that the moon's orbit is the moon takes lesser time to complete one orbit due to the smaller orbital radius. Over here you see the orbital radius is much higher than over here. So when the radius is smaller, obviously the circumference will be smaller, and hence time taken to complete one orbit will be smaller. Okay, next part, question number 2. Describe what is meant by the term vector quantity. Okay, there are two types of quantities. One's a vector, one's a scalar. So vector quantities are those which have a magnitude, or they have a size and they have a direction of movement. Scalars have a magnitude but they don't have a direction of travel. So we'll be writing it here. 2 marks. 1 mark for it is a quantity which has a magnitude and a direction. Magnitude and direction, these two words will give you 2 marks. Complete the table by ticking the correct boxes to show whether each quantity is a scalar or a vector. So here we know the first one has been done for us. Energy has a magnitude but we cannot tell which direction it moves. Speed, again, speed has a magnitude but it does not move in a specific direction. Weight, we all know, has a magnitude and it has a direction. On earth everything is moving towards the core of the earth, so it has a direction. Acceleration also has a direction because for example, when we're driving, we'll say we're accelerating forwards or we're decelerating which means we're slowing down or we're moving backwards. Means acceleration has a direction. Charge does not have a direction, but it has a magnitude. And moment has a direction. Moments are basically, here's the pivot, for example, of a door handle. Moving anything like this around a pivot, it's called moments. So moments is either this way or this way. So it has a direction of travel. So we're done with question number 2 as well. Here's question number 3. This diagram shows a part of a roller coaster ride. The car is pulled towards point A and then released. Choose letters from the diagram to complete this sentence. Here's the sentence. The car experiences the greatest downward acceleration at point. Here we can see the steepest position is this part, and it has a letter over here which marks that this point has to come in between any of these blanks. And the fastest downward acceleration, where the car is accelerating most in the downwards position, it is obviously B, because it's the steepest downwards. B. At C, it will be won't be accelerating downwards, as we can see. It makes sense. And at A as well, it barely has started to accelerate. And D, obviously it's not downward acceleration. And it has the most kinetic energy at point dash. At A, the kinetic energy is not the highest, it's the GP is highest at this point. Over here, no, but at the point C, when the car has moved down, GP has transferred to kinetic energy, and when it's moving upwards, it will be transferring back to GPE at point C. Okay. The maximum gravitational potential and energy of the car is 380 kilojoules. The maximum height of the car is 45 meters. Calculate the mass of the car. So the equation is already given over here. So all we need to do is substitute the values. Gravitational potential energy is given over here as 380 kilojoules. So we will be converting it to joules by multiplying it by 1000. Next, mass we have to find, so we'll just write this. G, you can either use 9.8 to be more precise, or you can use 10, which is actually preferable because it's easier to calculate, and Edexcel actually wants you to write it this way. And the height we know over here is 45 meters. All we need to do now is make the calculations. 380,000 divided by 450. Make sure you have your calculator with you and all kinds of equipment which you require. And we get the answer as 844.4, but we'll be writing it as 844 kgs. So we're done with this. It is preferable to write 840 kgs because Edexcel likes it in two significant figures or rounded off quantities. So here's question number 4 as well. They're quite short questions at the start. A copper cube has a mass of 0.0717 kgs. Calculate the weight of this copper cube. Give the unit. Okay, the mass is kgs. Whenever weight comes, we know weight is always in newtons. So whenever you're converting kgs to newtons, you always need to multiply kgs by 10. So it will be 0.0717 multiplied by 10, which moves decimal 1 place forward. So it will be 0.717 newtons. Here's our answer. Part 2. State the equation linking density, mass and volume. I'm sure everybody is aware of this. So density is equal to mass over volume. Mass divided by volume. Okay. Part 3. The density of copper in this cube is 8960 kg per meter cubed. Calculate the volume of this cube. So again we will be substituting our values in this equation. So density over here is given to us over mass is also given to us, which is 0.0717, because mass over here is in kgs, so you won't be using the weight. Mass over volume, volume is unknown to us, so all we need to do is make the calculations. Volume is, when you move volume over here, this one moves down over here. 717 divided by 960, what we get? 0.5 zeros and 8. So it's better to write it in standard form like this: 8.0 multiplied by 10 raised to the power minus 6, or you can also write it in 0.000008, but it's easier to write it in standard form, so I'll prefer you write it like that. Question 4, part B. The graph shows the masses of some materials when their volume is 1 meter cubed. So you can see the graph over here. These are the materials, these are the masses, and the volume of each of them is 1 meter cubed. Part 1. State the type of graph shown. You can write histogram, but yes, you can write histogram, but we will be going by bar chart. Use information from the graph to compare the densities of granite and steel. So this is granite, here we have steel. So you know volume, both of them is 1 meter cubed, but the mass of granite is lower than that of steel. So you can just you don't need, they're just telling you to compare the densities and not just not say how. So you'll just be comparing these densities. You'll just say steel is denser, 1 mark, and it is denser by how much, you can say like that. So let's just quickly calculate the density, mass over volume. So mass over volume is 1, so whatever the mass is, that's the density. So steel is about almost 8,000, while granite is close to 2.75, so you can say about 3 times as much. So it is denser by 3 times as compared to granite. They are 2 marks. Next is a blank page. Question number 5. This question is about sound. Describe any investigation to measure the speed of sound in air. You may draw a diagram to help your answer. In our previous paper which we completed, we talked about this, that whenever you're finding out about speed, you will always be using distance and time. So we will be calculating that. But first let's talk about what the experiment will be. So I will be drawing it here. One student over here, let's say, is holding 2 symbols. My drawing is not too great, but it works. So the other student stands about, let's just say, a calculatable distance in which you can actually see the difference. Let's say it's 30 meters. Another student over here is holding a stopwatch. Now what we do, this student smashes the symbols once. When this student sees this student collide the symbols, he will start the stopwatch, and when he hears the sound, because light travels faster than sound, so he will be seeing him collide the symbols before hearing the sound. So when he hears the sound, he will stop the stopwatch, and then he will use that time, and using this distance over time, he'll find the speed. So for 6 marks, 2 marks are one mark out of this 6 is for specifying an instrument used for one of your processes, and 1 mark is for precision measurements or for carrying out an average to make your reading better. So first of all, as we talked before, first set up a distance of 30 meters. 50 meters will be a bit too far away, so it will be hard to identify when he's hitting the cymbals, but while it will be easier to hear the voice. So 30 meters, it will be easier to see the person and identify the difference between both the sound and the light. So okay, on one end, one student stands with a pair of cymbals. You can also write clap, but clapping will be really hard to hear from 30 meters distance. And on the other end, another student stands with a stopwatch. Now you'll be explaining the process. He starts the stopwatch when the other student clashes the cymbals and stops it when he hears the sound. This will give you the time taken for sound to travel. Next, they will use the formula speed is equal to distance divided by time. Now we have our speed, but now for 1 mark we will be making this further more accurate. Repeat the experiment multiple times and find the average after removing any anomalies. There. So now you have earned your 6 marks. First, calculation of distance. Next, way to calculate time. Third, use of stating of any instrument. We used a stopwatch. Next, detail of the setup we did. Further, next, repeating our average and use of formula speed is equal to distance over time. We have 6 marks. Part B. The speed of sound changes when the temperature changes. A student investigates how the speed of sound in air varies with temperature. The student's results are shown on the graph here. Draw a line of best fit on the graph. Make sure you have a sharpened pencil with you and a ruler, plus an eraser if you need to erase and redraw your diagram line. So a best fit line means that a straight line that almost goes in between all these points, as if you're taking an average of these points and not necessarily touching each point. So I think it will be nice enough if I draw like this. So it's going through the gaps between these points. So let's just say it's our average. It should have been a bit downwards from this side, or it should have gone like this, but it is what it is. So we're done with part 1. 1 mark, easy. Use the graph to find the speed of sound when the air temperature is 20 degrees. So our temperature scale is over here, independent variable. Yeah, so at 20 degrees C we have to extend our line actually. That gives us about line tail here. So at 20 degrees over here, mine is hitting the second last block over here, which takes me there, which means from 340 to 345 it took 2 boxes. So 2 boxes actually mean 1 block. 341, 342, 343, so it's 341, 42. So this is 344. Speed of sound will be 344 meters per second. So we know what the speed of light is, 341. It's close to this, 341 actually. So we found out that it's about 344, which is close enough. So next part is part 3, which will be the last thing we will be doing today for our first part of this paper. A ship moves about in fog. A foghorn is used to make a loud, low-pitched sound to warn any nearby ships. The air temperature decreases while the foghorn emits sound waves of a constant frequency. Explain how this decrease in temperature affects the wavelength of the sound waves. Okay, pardon, there's a little glue stuck on my table. Okay. So whenever the temperature is higher, the air particles all around us are moving in a higher speed, so they can transfer information including sound in a faster way. But when the temperature is cold, obviously the particle will be moving a bit slower, so the transfer of sound will be a bit slower. So our answer simply will be that the sound will be traveling slower because the speed of sound decreases with temperature, and hence wavelength decreases with temperature. So we will just write speed of sound decreases with temperature, and so wavelength decreases as well. Here are 2 marks. You're linking these two, you're linking the speed of sound with the wavelength and the temperature. So we are done with 5 questions. Now we're left with 4, and we will be finishing those 4 questions in the next video, which is coming soon. So like and subscribe. If you find any problem, please let me know in the comments below. Subscribe to my channel for more past paper videos of physics, chemistry and maths. Maths and chemistry will be my next target. The channel is new, so I haven't much content uploaded much content yet, but with support and resources I will be uploading those as well. So see you in the next video.